factor by grouping method. 9z squared plus 6z minus 8. What we're looking at here is, as with any problem that we're being asked to factor, the key word is factor. To understanding the goal of our problem that we're being presented. So factor is really expects us to end with a goal of turn this, sum of terms, there are three terms here being added and subtracted together. Essentially it's a sum of unlike terms, rises to the level of being a polynomial because the variables are raised to whole numbers, whole number exponents. The goal of taking an expression or a polynomial and factoring it is to express that polynomial or other expression as the product of two factors. Just turn this into multiplication, pure multiplication, of two factors. So let's write down what we have. Let's start at the beginning, and what we have is 9z squared plus 6z minus 8. It's a trinomial, but it's a polynomial that we are, polynomial factoring is best handled by first let's factor out first. Let's find the GCF and factor it out. What kind of GCF might we have in here? Well, GCF, the greatest common factor, easiest things to include or exclude are the variables. We see a variable of z in the first term and a variable of z in the second term. They're factors of z in the first two terms, but they don't appear in the third term, so we can't put a z in here. Then, we're looking also, we could look at that point, we could look at the numbers, and we have 3 times 3 in the 9, we have 2 times 3 in the 6, and of course 8 is 2 times 2 times 2 when we get all the way down to prime numbers. So I'm not seeing any numbers that are possible other than, of course, what's always a common factor with any polynomial is a greatest common factor of 1, positive 1 or negative 1. But it doesn't really help us, unless this is a prime polynomial, and even then, we would declare it as prime. So usually a GCF helps us initiate factoring, but in this case it doesn't. So what we have to do is look for a second method of factoring. What I'm going to do is I'm going to rewrite our polynomial, give us a clean copy, 9z squared plus 6z minus 8. We have a clean copy to work with that we need to analyze. And what we're looking at is a trinomial. It's like, could this possibly be a trinomial that looks like this, of this form? ax squared plus bx plus c. Is this what we're looking at? Well, let's see what we have. We have a variable squared. It's like, I would analyze it this way. Do we have a variable squared in the first term? Yes, we do. Is there a coefficient here that's a number other than 1? Yes, we do. Is the variable z that's squared in the first term, does it appear in the middle? Does it appear in the middle to the first power? Yes, it does. That's what this pattern is trying to indicate. If these pluses match, then the coefficient of that middle term is 6. So far we've identified a and b in this type of trinomial. If we put a plus in to match this plus, the constant at the end is negative 8. So we do have all the elements of an ax squared plus bx plus c trinomial. Yes, and we do have this. So the method of choice that we should use is we should use, in this case, we should use what is often referred to as the AC method. Use the AC method. I'll explain that. But it's also called the factor by grouping method. Now, factor by grouping alone applies to 4-term polynomials. But and it's kind of foreshadowing what it is we're going to do. We're going to use A and C and B, but we're going to use AC method to split the middle term. And when we create 2 terms out of the middle term, then we'll have a 4-term polynomial, and then we can apply factor by grouping. So that's why this method goes by both of these terms, titles, AC method and factor by grouping method. Okay. So here's what this method entails. We're going to make 2 tables. 2 tables. And the way we make 2 tables is just draw 2 giant capital T's like this. In the first table, we're looking for the factors of the number that we get when we multiply A times C. A in our trinomial is positive 9. C in our trinomial is negative 8. So those multiply together to make negative 72. Okay, the other table is whose sum is B. And B is positive 6. B is positive 6. So here's what these 2 tables are asking of us to find. We're looking for 2 numbers that when we multiply them together, they produce negative 72. But we're looking for the same 2 numbers that when we add them together, they also add to make positive 6. Alright, we always start on the factors table and we end on the sum table. And that's assuming, presuming that these numbers even exist. But here's what we're going to embark on. We're going to start with factoring. We're going to factor negative 72. And factors mean 2 numbers times each other. Well, we're definitely going to need a positive times a negative, but let's worry about that as we continue here, okay? First, I almost always try A and C to see if some combination of A and C, like positive 9 and negative 8, would work. But the fact is, positive 9 and negative 8, when I try them over here in this table, they add up to a positive 1. They're not going to work. The other thing we could do is try switching the signs on 8 and 9 to make 9 negative and 8 positive. But then we just, when we make 9 negative and 8 positive, then we add up to a negative 1. These numbers just don't have the right difference between them to add up to a negative 6. But all these numbers on the factor table, they would almost always, as long as they're correct numbers, they work in the first table. We need to come up with new numbers. So, 2 different numbers other than 8 and 9. So what I'm going to do is I use a technique to continue breaking down these A and C numbers and see if we can do anything else with them, like 3 times 3 for 9 and a 2 times 4 for 8. I'm going to take these 4 numbers and recombine them in some other way, like 3 times 2 is 6 and 4 times 3 is makes 12. Here's 2 new numbers, and I notice that, well, if we used 12 and 6 as 2 numbers in our factors table, one would have to be positive, the other one negative. If we made the 12 be positive and the 6 be negative, let's see what would happen. Like positive 12 times negative 6, that does make negative 72. And positive 12 plus negative 6 does also result in the sum of positive 6. So these are our numbers because they make both tables work. Okay, we found the numbers. Now how do we use them? These numbers, we're going to use positive 12 and negative 6. They're the same in both tables. That's what we mean by same pair of numbers make both tables work. Well, what we can do now is we're going to do, this is the end of the AC part in my opinion, because now what we can do is we take the original polynomial, 9z squared plus 6z minus 8. We're going to copy out the first term, and we're going to copy out, we're making room in the middle. This is the split the middle term part. We're going to split the middle term. This is called splitting. split the middle term into two terms. And we're going to take our numbers that we found of positive 12 and negative 6. And I'm going to write the negative 6 near the 9 next to the first term because I'm trying to set up for factor by grouping as the next process in this method. And I'm going to put the 12 by the 8 in the blank next to the negative 8 because they share a 4 in common, a factor of 4. The 9 and the 6 share a factor of 3. So this is setting me up very nicely for factor by grouping. So the thing is, though, these two middle terms have to add back algebraically. I have to add back up to 6z, positive 6z. So we just glue a z next to each of these magic numbers, these numbers that are completing this problem for us. I call them the magic numbers. Okay, now we have a 4-term polynomial. And of course, what method works for a 4-term polynomial? Factor by grouping. So the AC method got us down to a 4-term polynomial. The AC method got us down to creating a 4-term polynomial because we used A and C, and B, but it's called AC method. But now, from here down, from here to the end, because it's a 4-term polynomial, we just do plain old factor by grouping, the way we would try on any 4-term polynomial. Okay, so here comes factor by grouping. We may not have had a GCF useful at the beginning, but a factor by grouping is trying to get us to look for a common factor just in the first two terms. And I'm seeing that 3z can come out of these first two terms, and that would leave us behind. I'm going to go ahead and change colors because it's easier to look at factor by grouping in color to see how the final answer assembles. So it's going to leave a remaining binomial of positive, when we look at 3z, and I'm using the positive version of 3z, positive times positive makes positive 9z squared, 3 times 3, and z times z. That gets us this 9z squared to come back. And when we distribute to the second term to make this term come back, I need positive times negative this time, 3 times 2, and we don't need any other z's in this green blank because all the z that we need for the second term here is z to the first. Okay, in my version of factor by grouping, I'm going to copy this remaining binomial under these last two terms. I'm just going to copy positive 3z minus 2 under these last two terms, and then ask myself, what would need to belong in this blank so that everything I need times this first term give me positive 12z back. Now, to make positive 12z, to make the positive, I need a positive. Times positive makes positive. What times 3 makes 12? A 4. Do I need any more z's in this red blank? No, because we're only trying to make z to the first come back. So it's working. We found something that we need to make this third term in the 4-term polynomial come back. Now, the check is, when we distribute positive 4 to this term, do we get negative 8? Yes, we do. Look, positive times negative makes negative. 4 times 2 is 8. Factor by grouping is working. Okay, so what we're finding is that the GCF really of this polynomial is 3z minus 2 because it's a binomial that appears in a form of factoring in each of these two kind of giant terms here. And what we can do is create an open binomial and complete our factoring. This first 3z is going to complete the first term of this remaining red binomial, and plus 4 is going to complete the second term of this remaining binomial, so that we get back what's above it. Now, of course, we could check these terms. We should check them, to be honest. If I wanted to make sure I got an A on my exam or my test, I really would want to check my factors. And the easy way to check them is by FOIL. I'm just going to, this is a check step, check to make sure these two factors are correct. So I'm going to go F, O, I, I'm just foiling because they're two binomials, L. So the f in FOIL gives me positive 9z squared. The O in FOIL gives us positive 12z. The I in FOIL gives us negative 6z. And the L in FOIL gives us negative 8. These two terms are like terms, which leave us with positive 6z. And there's no other like terms, negative 9z squared plus 6z minus 8. No other like terms to combine. So we're going to compare these now to the original polynomial. They should have regenerated. These two factors should have regenerated all the terms in the original polynomial. Do we have a 9z squared? Yes, we do. It came back with the correct factors here. Hopefully they're correct. Positive 6z to the first. Do we have that in the original polynomial? Yes. Here it is. And minus 8. There it is. All of our original terms came back. So we're looking for an answer that contains 3z minus 2 as a factor and 3z plus 4 as a factor. We would call these the correct factors. So let's look for them. 3z minus 2. Do any of these answers have 3z minus 2? Well, there it is. And it's okay that they're out of order as long as they both appear times each other. And then a 3z plus 4 factor. 3z plus 4. 3z plus 4. Well, I only see it, both of the correct factors that we found, in answer D. None of the other answers contain the correct factors. Only answer D. Hope this helped. Thank you.